When Apache Hadoop was first created, it was two important innovations. One was a scale-out storage system, the Google file system, later HDFS, that could store any kind of data very inexpensively, reliably. The second component, and a very important part of the ecosystem, was a new processing and analysis framework. That engine, called MapReduce, let you analyze huge amounts of information from HDFS very efficiently in massive parallel. The mistake that a lot of people made in those days was in believing that MapReduce was the way you did data processing analysis in the Hadoop ecosystem. We believed at Cloudera that other engines not only were possible, but were certain to evolve. There's no question that Spark is one of the most interesting such engines. Spark is an Apache Software Foundation open source project. It's a flexible in-memory framework that allows it to handle batch and real-time analytic and data processing workloads. The developers of Spark at Berkeley learned a lot from MapReduce, why it was hard to program, what the performance challenges were, and they addressed them very, very well. Most of all, though, they built a really interesting open source project with a really robust open source ecosystem, a global community of developers that worked hard on making that project better. We got involved very early in that process, but we've absolutely seen interest shift from old guard MapReduce to Spark, this new general purpose analysis engine for general purpose workloads on the platform. And that's absolutely going to continue in the years to come. Coding MapReduce is a real bear. It really does require a lot of Java code and mastery of difficult APIs and abstractions. It's hard to build long, complex processing jobs in MapReduce. You have to iteratively do a bunch of work. Spark makes that so much easier. The APIs are very well designed. You don't have to break your job into a whole bunch of little steps and chain them together. Spark lets you describe the entire job and execute it in much better parallel form than was ever the case before. It integrates very well with the popular languages in big data. So Python, first-class citizen. Scala, Spark is written in Scala, so it's very easy for data scientists building in that language to use it. And of course, Java and other languages are also well supported. So the very best tools for the job integrate beautifully with Spark, and it was designed by developers to be easy to use. You know, as the big data ecosystems matured, appetite for big data processing and analytics has really expanded. So it used to be the batch mode was plenty. We've seen a lot of interest in real-time and streaming workloads, complex event processing. I mean, those are things that you couldn't do 4 or 5 years ago in Hadoop. Now you absolutely can, and there absolutely are customers who demand those capabilities. Spark's architecture makes it uniquely well suited to stream processing, stream ingest, continuous query style workloads. It was built the right way in order to enable that. So this general purpose framework turns out to be really good at that particular special purpose workload. And that's important. You could always go build a special purpose stream processing engine for the Hadoop ecosystem. In fact, there are a number of pretenders to that throne. There are a number of good implementations that people built in order to try to solve that problem. What we've seen happen over the last couple of years is a real consolidation around Spark streaming as opposed to a bunch of other alternatives as people begin to roll these out in production. We've been able to sit back with the global community in general and observed which ones were successful in practice. Darwin has kind of chosen Spark streaming as the best answer. It's not just that it works well, but that it's so easy to code against. It really makes developer productivity a lot better. So stream processing and continually rescoring your models and serving results in real time, that stuff is now possible in the ecosystem because of the framework of Spark. Spark's used for some very important production business problems in the real world today. Financial services sector, huge consumer of Apache Spark. And there are a lot of workloads there. So for example, if you are looking for fraud in transaction flows, you want to continually retrain your model and you want to update your model scores, your predictions of fraud in real time. Spark absolutely lets you do that. If you've got more iterative processing, so I want to figure out how much my portfolio is worth, I want to do a value at risk analysis. Again, Spark is ideal at that. We see workloads across a whole bunch of vertical markets though. In the health services sector, we've got customers that are scoring and predicting onset of disease and disease conditions in their patient populations using Spark, again, in production and real workloads today. I do think that most new analytic and data processing workloads are going to preferentially run on Spark. Heck, we see older tools, Hive, Pig, Crunch, Scoop, migrating from MapReduce to Apache Spark because it is so much easier to build on. I think that momentum is going to continue and accelerate in the years to come. I don't think there's a one-size-fits-all answer to big data. MapReduce, as I said, is very important for an important class of workloads. It'll continue to play that role. If you need very high performance analytic queries, there's really no better architecture than a massively parallel special purpose database system. And that's exactly what we designed Impala to be. Likewise, if you know you're going to be doing document indexing, you can build special purpose interfaces and systems to do that. And that's what Cloudera Search has done. The nice thing about Hadoop is that it gives users a toolkit that's much richer than they ever had before, without forcing them to move their data. They don't have to pick up stuff from a relational system and drop it into an analytics system. All the data is in one place. Not only do I think Spark won't be the one processing engine to rule them all, but Spark won't be the last engine that gets introduced. Our job as a vendor, our job as an innovator in the space, is to keep our eyes on those new developments and be sure that we're driving and participating in the new engines as they come out.